we're going to continue on in the 6.4 notes. And now that we know how to graph the parent functions for sine x and cosine x, we're going to carry on and start doing transformations of these functions. And our goal by the end of these notes is to be able to graph something of the form f of x equals a times sine of bx minus c plus d, or similarly a times cosine of the quantity bx minus c plus d. Whenever we graph sine or cosine, we are going to do, we're going to put key points. They occur at intervals of a quarter period. And we're going to begin by looking at vertical and horizontal dilations. The first function that we're going to try to graph is f of x equals 3 sine x. We're going to begin by sketching the graph of the parent function, and then we will graph the transform function. So for this function, the parent is sine x, and we know that sine x starts at 0, 0. So this is going to be y equals sine x. And then I'm going to set the scale. I'm going to do each unit on the y-axis is 1 unit, and you need to put scales on your graph. And I know then that it starts at 0, 0, and then the next point, a quarter period later, the period's going to be 2 pi on the parent function, is going to be at a maximum, so that's pi over 2, 1. Another quarter period over, so at pi, it's going to be at 0. Another quarter period over, 3 pi over 2, we're going to have negative 1. And at 2 pi, it's going to be back to 0. And I continue on with this pattern, going from the midline to maximum, midline to the minimum, and then back to the midline, etc. So this is the graph of y is equal to sine x. And now I'm going to graph in blue 3 sine x. So what does this 3 do to my function? That is a vertical stretch by a factor of 3. That's the way we used to talk about it. Now we're going to use some different terminology when we're talking about trig functions. So what's going to happen is all the y values are going to be multiplied by 3. So I can take the points from the parent function, simply multiply the y values by 3. So I was at 0, 0, 0 times 0, 0 times 3 is still 0. Then I was at pi over 2, 1. When I multiply 1 by 3, it's going to go up to 3. Pi 0, 0 times 3 is still 0. 3 pi over 2 is at negative 1. Multiplying negative 1 by 3 brings us down to negative 3. 2 pi, the y value is 0. 0 times 3 is still 0. 5 pi over 2, 1 is going to go to 5 pi over 2, 3, multiplying the y value by 3, etc. And now I can graph y is equal to 3 sine x. So this is y is equal to 3 sine x. All right, let's talk about characteristics for y equals 3 sine x. The domain is negative infinity to infinity. The range now, instead of being negative 1 to 1, has been stretched to negative 3 to 3 inclusive, so use square brackets. The period, how long does it take to complete one full cycle? So let's do one full cycle. We can start here at the midline and do one loop going up and one branch going down. That will be one full cycle. That takes us from 0 on the x-axis to 2 pi. So the period here hasn't changed from the parent function. The period is still 2 pi. Okay, the amplitude. So let's go over to this box on the right. The amplitude, we talked about this a little bit last class, is the distance between the maximum and, it's half the distance between the maximum and minimum values of the function, or the distance from the middle, so that's axis of oscillation, to the top or the bottom. It's always a positive number. So if we look at this function, the minimum is at negative 3, the maximum is at 3, the distance between negative 3 and 3 is 6, half of 6 is 3, so the amplitude is 3. The other way to think about it is you can just go from the midline here to the maximum, so that would be 3 units, or from the midline to the minimum, which would also be 3 units. So we have an amplitude of 3. So instead of saying a vertical stretch by a factor of 3, when we talk about sine or cosine, we're going to say it has an amplitude of 3. What's the transformation that caused this change? We have a vertical stretch by a factor of 3. So back to the box on the right, for the amplitude, if we have a function a sine x or a cosine x, the absolute value of a is going to be the amplitude. Remember, the amplitude is always positive. The amplitude can be thought of as a vertical stretch. So we're going to put this, vertical dilation, not stretch, because it can be a stretch or a shrink. And if the absolute value of a is between 0 and 1, so something like a half or a third, it's going to be a vertical shrink. But if the absolute value of a is greater than 1, it'll be a vertical stretch. So that amplitude will be getting larger. On the next page, we're going to talk about the period. Okay, the period of the parent functions for sine and cosine is 2 pi. That makes sense because each time we go around the unit circle, we arrive back at where we started. That will create one full cycle. So a sine or cosine function will complete one cycle when its input goes from 0 to 2 pi. That's for the parent function. But what happens to the period when we have a function of this form? So if we have a sine bx or a cosine bx. So now we are multiplying the input x by b. So we have bx and not x. So this function is going to complete one cycle as the input bx goes from 0 to 2 pi. So what does this mean? We can solve this. We can solve that bx is equal to 2 pi. That's how long it's going to take to complete one cycle. So the period then, if we divide both sides by b, so x is going to be 2 pi over b. So that's going to be the period. Always for sine or cosine, if we take 2 pi and divide it by b, that is going to be the period. That's something you're going to want to remember. Okay, and that's true for b is greater than 0. If b is negative, that has to do with the reflection. So we really always just take the absolute value of b when we're figuring out the period. If the absolute value of b is greater than 1, so that means the period is less than 2 pi. Remember, when we have horizontal stretches or shrinks, we do the inverse operation. So if absolute value of b is greater than 1, the period is less than 2 pi, which represents a horizontal shrink. And if the value of b is between 0 and 1, the period is greater than 2 pi, which is a horizontal stretch. Okay. Oh, here I have the note about period always being positive. So if b is negative, to find the period, remove the negative from the argument. So you would just divide by the absolute value of b. All right. Now we are going to graph the following function. So we want to graph f of x is equal to cosine of 1/2 x. We're going to begin by graphing the parent function, and then we will transform this function. Okay, so the parent is y is equal to cosine x. You need to remember that cosine begins at the maximum value of 0, 1. I'm going to let 2 lines be 1 unit on my graph. So cosine is going to start at 0, 1 for the parent function, and then every quarter period, which will be 2 pi times 1/4, I'm going to get a key point. So at pi over 2, it's going to go to the midline. At pi, it's going to go to -1. 3 pi over 2 is back to its midline, which is 0. 2 pi is at 1. 5 pi over 2 is 0. 3 pi, -1. And we can do the same thing in the negative direction. I'm actually going to use a dashed line this time to graph the parent function. So this is y equals cosine x, which is the parent. Okay, now to graph cosine 1/2 of x, there's more than one way to think about this. One way to think about this is it's a horizontal stretch by a factor of 2, right? We really multiply x values by 2. So every time I have an x coordinate, I multiply it by 2. So I'm going to graph this function. So I was at 0, 1. 0 times 2 is still 0, so I'm still at 0, 1. Pi over 2, 0, multiplying the x value by 2 would put me at pi. I used to be at pi negative 1. Multiplying pi by 2 would go to 2 pi, so I'm at 2 pi negative 1. 3 pi over 2, 0. Multiplying 3 pi over 2 by 2, the x value would put me at 3 pi 0. And I was at negative pi over 2, 0. Multiplying the x value by 2, negative pi over 2 times 2 would put me at negative pi 0. And now I can sketch the transform function, y equals cosine of 1/2 x. Let's do the analysis. So the domain of y equals cosine 1/2 x is negative infinity to infinity. It's all real numbers. The range is going from, if we look at these values, negative 1 to positive 1. We didn't change the range at all. So it's still negative 1 to 1, same as the parent function. The period is going to be 2 pi over b. So 2 pi b is the coefficient of x. So it's 2 pi over 1/2, which is 4 pi. And then the amplitude is the coefficient in front of cosine, which is 1. So the amplitude is 1. We didn't change that. And rather than doing the horizontal stretch like we did, an alternative way to do this from the beginning is we could have taken the period, which was, well, we just did, the period is 2 pi over 1/2, which is 4 pi, and then key points occur every 1/4 period, which will be 1/4 times 4 pi, which is pi. And we could have used that to find our key points, because our first key point would be at 0 and 1, and then every pi unit, so at pi, 2 pi, 3 pi, we would get the key points. And as you can see here, I've got 5 key points that I just circled in green for the cycle. Now that we understand what the amplitude and period are for graphs of sine and cosine, we can look at an equation and determine what the amplitude and period are going to be pretty easily. So I have my first function, y equals 5 sine x. If I want to know the amplitude, I think about the vertical stretch, and the amplitude is just the absolute value of that coefficient in front of the function. So the amplitude of this function is 5, and the period is always 2 pi over b. So in this case, b is equal to, this is like 1/2 times x, so b is equal to 1/2. So 2 pi over 1/2 is 4 pi. So this graph has a vertical stretch by a factor of 5 and a horizontal stretch by a factor of 2 relative to the parent function. Next function, we're going to look at f of x equals negative cosine of 3x. So the amplitude, don't get tricked here, the amplitude here is not negative 1, but 1, right? The amplitude is always positive. So you need to take the absolute value of a. B in this case is 3, so the period is going to be 2 pi over b, which is 2 pi over 3. So this is actually a horizontal shrink. And the last one, we have 1/4 sine x over 4. The amplitude is 1/4. This is the same as 1/4 x, so b is 1/4. The period is 2 pi over b, which is 2 pi over 1/4, which would be 2 pi times 4, which is 8 pi.